Hi, welcome to part 2 of the Godot Tactics tutorial. This is Digital Workbench, and I'm 7 Sage. In this lesson, we'll be writing our first few scripts in GDScript to make our board creator, as seen in the background. I will be going into this series with the assumption that you have at least some programming knowledge. GDScript is very similar to Python, but you should be fine even if you don't know either of those as long as you have some experience in another language, as you should be able to pick up the GDScript specific syntax as we go along. If you missed the first video, I left a link in the description to the playlist. And also for this lesson, I've updated Godot to version 4.5.1. Before we get into our first script, here are a couple notes about GDScript. Lines do not end in semicolons. Instead of curly braces, we use indentation to denote blocks of a loop and such. Also, if you are used to using spaces instead of tabs, I'm sorry, but GDScript requires tabs. Which means you may have to be careful if you copy any code from the web, since websites frequently convert tabs to spaces. If the website has a button for raw code, you need to click that to get the version with the tabs intact. Comments use the pound sign. If you want to comment out a group of lines, the simplest method is just to select multiple lines and select toggle comment. We can do the same thing to remove the comments. Okay, let's get started. Let's create a folder inside the scripts folder named View Model Component. To do this, right-click on the scripts folder and choose Create New Folder. This is roughly based on the MVC design pattern. Once you have a folder created, right-click on it and choose Create New Script. Give the script a name, tile.gd. Leave the rest of the path as is. If we leave template unchecked, the script will be created mostly blank, with only extends node at the top. If we create the script with a template enabled, it will create a couple common classes that we'll frequently see. At the top is extends node. This is the class the script inherits from, and node is a lot like monobehavior in Unity. Next, the two functions ready and process are similar to awake and update in Unity. For this script, we can delete everything except for the line at the top, extends node. The board creator we will be making will display our board in the editor without the need to press play. Because of this, we need to tag the scripts we are using to tell the editor it needs to run them. At the top of the script, add the keyword tool with an @ sign before it. We'll need this on most of the scripts this time around. Along with tool and extends node, we'll add class name tile. This will register the name in Godot and let us compare its type or create instances of it. It is also needed if we want to extend the class. Next, we'll create a const for how tall each tile will be. Unlike Minecraft, each block will not be a completely square cube, but instead something with smaller steps. We do this as a const so we have a central place we can change the value if we decide later on that something else looks better, and only need to change it in one place. It also eliminates a magic number in our code. In 6 months, step height will make more sense than seeing 0.25 somewhere in our code. In the original Unity version of the tutorial, we created a point class, which was essentially a 2D vector with the values both being ints instead of floats. But later versions of Unity and Godot already have types for that built in. In Godot, that is vector2i. We need to create two variables, pause for the position of type vector2i, and height of type int. Center is a convenience function that lets us get to the value of the top edge of a block, useful for placing objects and characters on the surface of a tile. Anytime a tile is modified, we'll need to call match to set its scale to the correct height. First, we scale the tile to the correct height, and then, because the pivot point is at the center of the tile instead of the bottom, we need to actually move the tile up half the height to get it in its correct place. The board will be created by growing and shrinking tiles. There is no logic here for capping the max and min height. We'll be taking care of that in the board script. Whenever the tile is updated, however, we need to update the scale with match. Last up, we create a function to set a specific height and position of a tile. In C#, we would be able to overload the function to use multiple signatures, but GDScript does not support that. So we'll have to use two different names for each function, load and load vector. Save the script. Now that we are finished with that script, we need to attach it to our tile prefab. Open the tile scene and click on the tile node. In the inspector under node, you will see a value for script. Click on the drop-down and choose load. Find the tile.gdscript in the Explorer and add it. Alternately, you can drag the tile.gdscript from the file system pane onto the tile node. Be sure to save the scene. Now at this point, I want to deviate a tiny bit from the written version, though the changes will still be fairly compatible with that version. In the original Unity version, the board creator was a single script, and then a stripped-down version was created later to use in the regular game outside the map creator scene. In the written version, I skipped creating a simplified version and just used the whole script so I would potentially have access to it in later scripts. Now, I want to try taking an approach somewhat in the middle, splitting some of the board creator specific stuff into its own script, while keeping the core components in the board script. Along with that, I also want to implement some other changes that will simplify our code a bit that weren't available in the earlier 4.1 version of Godot. I'll also show the old way of doing it if you have an older editor. In the View Model Component folder we created earlier, create a new script named board.gd. Like the tile script, we need to add tool and a class name to the script. We'll call this one board. The export keyword will let us see and edit the variable from the inspector. Height is the max height for tiles. We can just increase this number if we want to allow taller tiles. The next variable, pause, for the position of type vector2i, will store the location used by the yellow indicator we created. I changed the code a little here so I wouldn't need to check if it had changed every update. Using a getter and setter, we can get the variable like normal, but when we set it, we update the marker at the same time. Next, we need a variable to reference the tile and selection indicator prefabs. You can drag the prefab onto the script editor for it to insert the path automatically. Tiles is the dictionary that we'll use to store the location of each tile. Not every location will have a tile. Some will potentially be blank. The curly braces denote that we are creating a dictionary. Square braces are used for arrays. Marker will hold the actual selection indicator once we initialize it in the scene. In this script, we originally used ready, but I found I was getting some race conditions when I updated the pause variable, so I changed it to init which is the constructor for the class. In this function, we're setting up the tile selection indicator. Next, clear. We loop through the tiles to clean up any that were previously created. For update marker, if the tile dictionary contains the position, we set the selection indicator to the top of that tile. Otherwise, we set it at the height 0. Grow single. We call getCreate to either get the tile at that location or create a new one and then increase the height of the tile. We call update marker when done to make sure that the indicator still lines up. Shrink tile is similar, but we need to do nothing if the tile doesn't exist. And if we shrink it to 0, we delete it entirely. getCreate, we check the dictionary for the tile and return it if it exists. Otherwise, we call create to create a new tile. Load then sets the position of the tile and sets the initial height to 0. Create, we instantiate the object and add it as a child to the board. Before we add the save and load functions to the board script, I'd like to talk about some of our options. In general, I think there are 3 main choices. We can load a resource file, which is similar to a scriptable object in Unity, although that could potentially be unsafe, though I'm not sure if it has been fixed. The problem lies in that resource files can include anything, including code. Because this is an editor script and not a player accessible file, unless you are providing it as a level editor, then it should be fine to use. But I think it's best to probably avoid that for things like save files. The next option is that we can write and read the data from a binary file. This option is a bit harder to read, but it is my preferred method. The third option is JSON. It's a bit more complicated to write, but it keeps things more organized and is easier to read, which, depending on the situation, could be a plus or minus. As I mentioned earlier, this isn't player-facing, so we can really choose any of the options in this case. But I'll be giving an example of the last 2 options. There is one last choice to make. What should we use as the file extension for our maps? The file system pane in Godot will hide files of any type that it doesn't recognize. The files will still be there, but it will be more difficult accessing them inside the editor. .json works well assuming we are using JSON, but if we are using binary files, there isn't really anything that works perfectly. We can use one of the Godot specific formats, but I worry about confusing it with a different type of asset the program uses. So you can choose whichever format you think works best, and while it's far from perfect, I went with using .txt. While binary isn't exactly text, it at least won't be confused with the other Godot files. Now, before getting back to our script, let's create a new folder named Levels inside the folder Data to store our maps. This folder will need to exist before we try saving any files. Back into board.gd. I don't have any safety checks on opening the file here, but it should be enough to get you started. We open/create the file with write access. I added a version number to help us keep track of how the map is set up. If we make changes to the map format, we can choose what to do with the file if it is an earlier version. Do you fail to load it? Do you upgrade it to the new version? Do you load it but leave off features that are found in the new version? Also, to keep things simple, I saved the version as a single byte, so we can choose anything from 0 to 255. Also note that this doesn't have to be the same as the game version, but the version of the save format. Next is the number of tiles we are saving. This will let us identify which place in the string of bits to stop at before the next section, if there is one. Here we actually write the first bits to our file. 8 bits for the version and 16 bits for size, as we may have more than 255 total tiles in our map. And all that's left is to loop through our dictionary and save each x, y, actually z, and height, and to close our file once we're done. To load, we start off by clearing the map. We will check to see if the file exists and return if there is no map to load. This time, we are opening the file with read access. We need to get the files in the same order that we created them. Every time we call .get8 or .get16, it grabs the next section of bits in the file. So if we change the order, we'll be grabbing the wrong bits. We'll use the size variable to determine how many bytes to loop through to get our tiles. We'll save x, z, and height. Once we have all three values, we'll create the tile object and set the values. Once we are all done, we close the file and update the marker so it is at the top of the tiles we created. Unlike the previous example, JSON is a plain text readable file. The trick here will be just getting the files formatted into a structure that we like. We'll convert everything we want saved out into one dictionary file, which JSON will convert into a text file. We aren't limited to simple bytes for our values, so I expanded the version number to be a bit more nuanced. We'll have one key for tiles, which will hold an array of smaller dictionaries for each tile. If you want to make it more compact, you could also create an array of vector3i's. Once we have all of our tiles saved into the dictionary, we'll create our save file, convert our dictionary into JSON, and save the data into the file. Like the previous file loading, we start by clearing the map. Next is to check if the file exists and opening the file. Next, we create our JSON object and parse the text. Assuming that goes well, we create a dictionary that will bring us back to the dictionary format that we created getting ready for JSON. After that, it's just a matter of looping through the dictionary and loading our tiles like in the previous set. Just like before, close the file and update the marker. Save the script. We'll create a new folder inside the scripts folder for the script named pre-production. Right-click on this folder and create a new script named boardgenerator.gd. Just like the previous scripts, we'll need tool at the top. We'll also give a class name and extends node again. Next, we need a few variables. We'll put the export flag with them again to access them in the inspector. Width and depth will be the max dimensions the board can reach on X and Z, while the height of the train is controlled within the board script. Speaking of the board script, we also need a reference to it. The next variable is the folder the maps will be saved to. Res is the root directory of our game. If we wanted to create something like game save data, we would probably use user instead, which saves to a separate file location dedicated to user files, such as app data. Two more export variables, one for the standard save and one for the JSON. Because they use different extensions, I separated them into their own values that we'll use later. Next, we'll create the actual buttons we need. In Godot 4.1, we needed a plugin, which I'll show how to set up at the end, to create the buttons. But since, I believe, 4.4, we now have the ability to add buttons directly in a script. We'll use export tool button. The text here will be the text on the button. We can also add a second parameter here that I believe changes the icon on the button. Next is the variable name, and the value after the equals is the name of the function that we will be calling when we click the button. We need buttons for clear, grow, shrink, grow area, shrink area, save, load, save JSON, and load JSON. The last variable will hold our random number generator that we'll use later. In the ready function, we randomize the seed value our generator uses. Random rect, the first two numbers are the x and y points at one corner of the rectangle, while the next two generated are the size of the rectangle. This means that no matter which first point we generate, we'll have a valid rectangle as long as the size is at least 1. Range returns an int between the two values. Unlike Unity, where the range is inclusive-exclusive, Godot both values are inclusive. For grow and shrink rect, we loop through the points we get from the random rect and make a call to grow single on the board object. The last functions we need here are the ones that we called by the buttons. For the most part, they all call their counterparts on the board's object, with the current pause or file name passed onto them. Clear is straightforward. We just call board.clear. Grow, we call board.growSingle and pass it board.pause. We can't just do this in the board because growSingle is responsible for all tile height changes, and it won't always be at the current position. Shrink is the same thing. Grow and shrink area, we created a random rect 2i and passed that to the growRect function we created earlier, which will in turn call board.grow or shrink single. For save and load, we combine the path and file name just before we use it. If we were to combine them when the program starts, it wouldn't take into account changing the name in the inspector. Load and save JSON are the same, but we use the file name JSON variable and call the JSON variants of the save and load functions. Save the script. Let's start building our board creator scene. Right-click on the Scenes folder and select Create New Scene. Create a new 3D scene named boardcreator.tscn. In the scene view, create a node 3D named board and attach the board.GDScript we created earlier. Next, create another node 3D named boardGenerator and attach the script boardGenerator.gd that we just created. Click on the boardGenerator node and in the inspector, assign the board to the board variable. At this point, we can test the board creator. If we have the board generator node selected, click on the buttons in the inspector. They should all work. And if you jump over to the board node for a moment, you can change the values on the pause variable to change which tile will grow and shrink. If you'd like to be notified of when the next video comes out, be sure to like and subscribe and hit the bell for notification. Now, if we were to actually play the scene, we wouldn't have access to these buttons in the inspector in game view. We also don't have any lights or cameras attached to view it. So let's deviate from the written version a tiny bit more and fix that. To create a light node, right-click and choose New Child Node like before, and in the search field, type Light, and find one named Directional Light 3D. Under Transform, set the X rotation to -30 and set the Y position to something like 10 to move it up out of the way a bit. Because it is a directional light, it doesn't matter too much where the light is located. For the camera, we'll create a few different nodes to better control the rotation. Create a node 3D and name it Camera Controller. Next, as a child of that, create a node 3D named Heading. And as a child of Heading, create a node named Pitch. And finally, as a child of pitch, create a child and search for camera and choose Camera 3D. We need to make a few adjustments to the transforms on the nodes we created for the camera controller. First, on heading, set the Y rotation to 45 degrees. On the node pitch, set the X rotation to negative 35 degrees. And finally, on the Camera 3D node, set the Z position value to 10. You can also set the projection mode to orthogonal and set the size to 10. When the camera is set to orthogonal, the position doesn't affect the camera for the most part, but if it is too close to the object, it can create some weird clipping. Next, we need to create another way to see the buttons. We'll start by creating a container node to hold all the buttons and line them up. Right-click and create a new child node of type VBox container. As a child of the VBox container, we need to create 9 buttons. Rename the buttons and set the text field to their corresponding names. We'll use the same list as before: clear, grow, shrink, grow area, shrink area, save, load, save JSON, and load JSON. Now to link these to the correct functions, instead of the inspector, we will go to the Node tab right next to it. Under Base button, click on Pressed. Select the board generator, and before clicking Connect, push the button Pick. And we should see our list of functions. Select the corresponding function for each button and click Connect. When you are done, be sure to save the scene. If the list of functions doesn't show up, make sure you've selected the correct node above and that you have the board generator script saved and attached to the node. Now we can click Run Current Scene and test the buttons. I prefer this over using Run Project at the moment, since this won't be our main scene. Test all the buttons to see that they work. If you have a map already in the viewport, save it before switching to running the scene. If you'd like to support me or find me around the web, you can find me on the places such as Patreon, Twitter, and itch.io. I've left links in the description. I've also created a Discord channel for you to ask questions if you get stuck, which I've also left links to in the description. With the previous examples, we don't actually need this anymore, but I wanted to include the plugin from the written version of the tutorial as well, so feel free to skip this portion if you want. In the past, we needed to make a plugin to add buttons to the inspector. These can be written in GDScript, so no need to jump into C++ or C# or recompile the engine or anything like that. Let's go to the project menu and select Project Settings. From there, go to the tab that says Plugins. Click the button Create New Plugin. In the dialog that opens up, enter Board Creator Inspector in both plugin name and subfolder. Enter a name under Author. Language will be GDScript, and finally, script name we'll use is plugins.gd. This will be the entry point for our plugin. Be sure to type the plugin name plugins.gd into the script name field. Even though it looks like the default will be plugins.gd, it will actually default to use the same name as the subfolder. Once you click Create, a folder will be created in the Add-ons folder with our plugin name, and inside will be a plugins.cfg file, which contains the info we listed in the form, and the plugins.gd file. Inside the same folder, we create one more script named boardcreatorinspector.gd. This will be the code for our buttons. Open the plugin.gd file. Tool allows this to work in the editor, and you'll notice that this time, instead of extends node, we're using Extends Editor plugin. First, we need a variable to store the plugin so we can load and unload it. Under Enter Tree, we'll preload the plugin and then call Add Inspector Plugin to load it. Then we will free it when we are done with Exit Tree with the Remove Inspector plugin. Open Board Creator Inspector.gd. This time, instead of Extends Node, we'll be using Extends Editor Inspector plugin because this plugin is modifying the inspector. Tool again because we're using this in the editor. This bit is where you tell the plugin where in the editor to show the plugin. If we just return true, it will show on all objects. Here, we only show the plugin if the object is a board generator, which is one of the reasons we named the class earlier. Here's where we'll put everything that we want to show. In this case, we're creating several buttons, the same as we created in the previous examples. We create the button with button.new, then set the button label with .setText. Then we connect the button press event to the method with the pressed connect. And finally, we load the button we created into the inspector. And that wraps up the plugin. If we click on Board Generator in the 3D scene, we should see our buttons in the inspector. If we don't, be sure the script and scenes are all saved, and you may need to open and close the scene file or deactivate, activate the plugin inside project settings where we created it. If there are errors in any of the scripts, you may have to fix them before it allows you to enable the plugin. Be sure to give them all a quick test to make sure they are all working and wired to the right functions. Remember to be careful with tabs and indentation. If things aren't working the way you expect, double check that all your scripts and scenes are saved. Also, be sure they are attached to their respective nodes. You may also need to make sure all your path variables are set to folder locations that exist. Check that all scripts from this lesson have tool and you have class name for board, board generator, and tile.gd. If the changes are still not showing up, close and reopen the scene, or if all else fails, Godot itself. So, I may have went a bit overboard in this one with all the options in this lesson. If you have any questions, feel free to comment below or check out the repository on GitHub. I've left links in the description. Special thanks to my patron, Joshua Strode, and special thanks to John Parham, the original creator of the Unity tutorial, without which this wouldn't be possible. Thanks for watching.